Hello there and welcome to another virtual tutorials video. My name is Elijah, and in this video we're going to be taking a deep dive into the bevel modifier. More specifically, we're going to look at the width type option inside the bevel modifier and try to demystify what each of these options mean for your bevel. We'll also do a quick overview of why not applying the scale makes the bevel go haywire. I assure you, you've never heard or seen the bevel modifier explained like this. So if you're ready, let's jump in. You're inside of Blender and you have a cube and you want to bevel it. In essence, what a bevel does is it adds new geometry in order to smooth out rough corners or rough edges, or I should say sharp corners or sharp edges of an object. So you all know that you can do this, and this can be done in one or two ways. So you know that if you have an object, say like this cube here, and we go into edit mode, and you come over here to the left side, you can actually just click on this and you'll see this little yellow line right here and this yellow circle. And then this is going to allow you to bevel the edges. Now what's going to happen here, as you know, this is going to be a destructive workflow. So as soon as it's there, and we're back to it, we're going to have all of this new geometry is going to be set kind of in stone, right? And there's nothing you can kind of go back to do to revert it. Of course you can do a Control-N-D and so forth, but as you bevel it some more, you're going to get more and more, and then you bevel again and you're going to get more and more geometry. And so now our perfect square has kind of turned into almost like a circle, right? So let's undo those steps there. Now, a better way potentially to work is a non-destructive workflow, and that is by using modifiers. So if we come over here to the right and we want to add a modifier, we want to add a bevel modifier, and here it is right here. We'll click that. And so those are the two ways to get into the bevel modifier. Hey, I hope you're enjoying the tutorial so far. If you like what you're seeing, don't forget to hit that subscribe button and the like button. It means a lot. Thanks so much. So say we have this cube here, and say we go into edit mode and we make this more like a rectangle instead of a cube. So let's constrain it to the Y and let's left click to drop that. Perfect. Well, according to our scale, nothing has changed, and that's because we did the transform inside of edit mode, as you can see up here. But what if we were to transform it in object mode? So let's do like a scale. Press S for scale, and let's constrain it to say like the x-axis, right? Let's scale this. So we're saying this is our new rectangle, and this is what we want it to look like. Well, now the scale is 1.989, and the rest of them are still at 1. So why is this problematic when it comes to creating a bevel? Well, let's go down here to this this demo that I've created. So let's see here. So why does the scale need to be applied? Well, let's take this object for example. So what it was that originally it was a cube, and we scaled it along the x-axis here to make it a little longer, but we did not apply the scale. And if you can see right here, we have a scale along the x as a 2. So essentially what's going to happen when we apply the bevel modifier is that it's going to basically bevel along the x-axis. It's going to bevel that 2 times as much as it does everywhere else. Let's look at this in aerial perspective here from the Z down. You can see that this, which is along the x-axis, since we kept the scale at 2/2 and everywhere else just 1:1, it's 2 times as big as this one, which is being scaled along the y-axis. And so this is the reason why applying the scale is so important, because if you don't do that, anytime that you're scaling, so let's go back over here, it's going to scale twice as long along whatever axis is. In this example, we have a 2, which is really easy for, explanatory purposes. It's going to scale twice as much as it is going to scale along the y-axis here, which is at a 1:1 ratio. And so that's why applying your scale is so important, right? So let's just say with this one right here, but what happens if we were to scale this, or at least apply the scale? So let's get rid of this bevel for a second. And so we have no more bevel on there, but we still have our measurement sticks here. and let's apply the scale. So we can go to Object, Apply, and you can do the scale there. I have an on-screen keyboard that I use, which helps me. So I'm going to apply all transforms here. And so as you can see, our scale just went back to 1. Now, if we were to go and apply the bevel, it's going to evenly distribute the bevels across the object, so that the bevel that you get along the X here, right here, is going to be the same that you're going to get along the Y-axis here. And so that's the reason why you want consistency in your scale. Okay, so you might have known that already, but I wanted to give you the why behind it, because I feel like people just kind of say, hey, just make sure you apply your scale, make sure to apply the scale, but they don't always exactly tell you why. And so that's why I thought that would be helpful. So the next thing you'll notice inside of the bevel modifier is you have an option to choose vertices or edges, right? And so if we were to, let's bring up an object here, and let's make this, let's get rid of this bevel on this object. Okay, perfect. So we have this situation right here. And let's say we wanted to add a bevel to it. So inside of the bevel, you have an option to choose vertices or edges. Now vertices is going to essentially, it's going to bevel around the vertices, as the name suggests. And as you can see, the scale is a little wonky, right? Because again, we didn't apply the scale. So let's see if we can apply that scale now. Apply the scale, there we go, perfect. So now you can see it's evenly distributed along all the axes, which is why we apply the scale. As you can see with the vertices, and this is in the offset width type, it's going to bevel around the vertices. Whereas if you click edges, it's gonna bevel around the edges, right? So what happens is the edge becomes smooth, and then at the point where the vertice was, it creates kind of like an intersection, is what they call it, to where the bevel can go around smoothly there. So far so good. So that's sort of the overall difference between vertices and edges, and we'll keep going so you'll get a better understanding of that. So also within the bevel modifier, you'll see width type, and this is what hopefully this video will be, maybe some new information for you. And you have different types. You have offset, width, depth, percent, and absolute. So we're going to talk about each of these, and we're going to do so in the context of edges and vertices. But with the edges, you'll understand a little bit more, and with the vertices, there's still some questions that remain, and I'm hoping you guys can help me with that. So inside of offset, what you want to do is we have a cube, and we have the offset the offset width type selected. And so what I've done is I've selected 6 inches or 0.1524 meters, right? Same thing. And so what happens in the offset is essentially you're measuring a perpendicular distance from where the edge was to where the new edge of the bevel is going to be, right? And this is consistent whether you're in edges or you're in vertices. As you can see within the vertices, it also measures perpendicular from where the edge was to where the new edge is going to be. Except within vertices, it looks very different than it does inside of edges, right? Because of the fundamental difference between those two beveling types. And so that's kind of offset. It's pretty self-explanatory. It's what the program defaults to. Some of the issue that you can run into it with it though is that because this is, at a 90-degree angle, it looks great, right? But as soon as you're beveling at a non-90-degree angle, you can get some weird stuff. So let me show you an example of that. We'll hide our measuring stick there for a second. So one of the things that I did here was this was a cube initially, and all I did was I took the face inside of edit mode. We'll go in there, and I just dragged it down along the z-axis. Well, look at some of the stuff that we're getting here. Essentially, it's trying to bevel along those perfect, perpendicular 90-degree angles, and it's just not working because we've got some non-90-degree situations going on. So here you're getting some compression, right? And now let's show it from this angle here. And here I stretched it. So I took the object and I just stretched it out a little bit. So here you're going to get some weird artifact stuff too, or weird shapes and weird you're going to get some weird beveling, essentially, is what's going to happen, because you're not at a 90-degree angle like this, and so it's kind of stretched and it just looks a little weird, right? There is a solution to that, and we'll go over that here in a bit. It's another width type. So let's keep going with our width types. So let's just say you want to do width edges, and we're gonna do the width type as width, which is kind of redundant, it feels like, but essentially let's show what that is. So let's go here, and the width type is essentially you are beveling according to the width of, as the name suggests, according to the width of the bevel itself. So just as a reminder, within the offset situation, you were going from where the original edge was into where the new edge is going to be, whereas with the width, it's actually the width of the bevel itself, right? So you can kind of see the difference. This is the width bevel, and then this is the offset bevel. So let's keep going here. Let's do depth. So depth, yet another beveling option. So we have, originally this was the offset, where the we begin perpendicular to where the original edge was to where the new edge is going to be. You have width, which is the width of the bevel itself, and then you had depth. So depth is going to take it from where the original vertex, where the two edges were originally meeting, and it's going to go deep into that object, and now you have where your new bevel is going to be, and that one's called depth. And so you can see the difference between those. Now with this next one is percent. So essentially what you're doing is you take you take this edge, right? And you determine how much of this edge do you want to bevel, or what percentage of that edge do you want to bevel. And so for our cases, if we were to do, apparently 7.66 is the same percent, or 6 inches is essentially 7.66% of this edge right here, right? That seems about right. This seems about 7.66 of this entire edge. So if we were to increase that, we can see how these are meeting together. And what's going to happen if you go up to 50%, you're going to get a very cool looking object, which is always kind of neat to play with. And you can do these things with the bevel. It's really endless once you understand how it works. But as you notice, we haven't gone to 100%. So how come it met in the middle? Well, the reason for that is because if this side is coming in at 50% and this side's coming in at 50%, they will meet in the middle and create those interesting objects. So let's go back to what we had here with our 7.66. And so now you can kind of see that whatever percentage you choose is the one that it will be. All right, let's talk about our last width type, okay, which is called absolute. And this one is indeed, to me, the trickiest to kind of wrap your head around. I definitely struggled with this one. Basically with the width type, or I'm sorry, yeah, with the absolute width type, the difference between this one and all the others is it essentially, the reason for the name absolute is it's an absolute distance from where the original vertex was to a new spot on the object. Let me kind of let me show you what I mean. So if I were to turn off this bevel, which I can do that by clicking this monitor button, this is the original object, right? As you can see, these are meeting at a non-90 degree angle. And so if you can imagine this vertex here, once we apply the bevel, this vertex is going to travel the 6 inches, and this vertex is going to travel the 6 inches, if you will. And so this is going to determine where that bevel is going to be. So let's apply it and let's see what happens. Precisely that. And this is the same 6 inches, the marker that we've been using the entire time. And so I'm going to turn on this situation right here. There it is. You have the 6 inches right here, and then that's going to determine the bevel amount. And so what are all of these various bevels used for? Well, that's a good question. So when it comes to, and just real quick before we move on, some people get confused between the difference between offset and absolute. Offset is the default bevel type, and it's good if you have like a lot of 90 degree angle corners. But when it comes to, like we went over, if you're dealing with non 90-degree angles, you can get some compression, you can get some stretching and so forth. And so that's where the absolute comes in. Essentially, if you've got a situation where you've got a bevel that's meeting at a non 90-degree angle and you want to maintain sort of the correct proportion or the correct curvature of that angle, you're going to want to use absolute. And I can kind of show you the differences here. Let's just say if you're looking at offset here, it doesn't look bad, but you can kind of see the difference here. If we were to do absolute again, it just kind of maintains the angle of the shape a little bit more. That's the best I can do to kind of explain it. I think the more important thing is, what are the applications for each of these? Like, when would you use which width type? So for offset, if you're just looking for something quick and something easy, it's the default. It can kind of be your go-to, right? It's gonna kind of angle everything from that 90 degrees as we talked about. You can get some problems with it though, and that's where absolute can come in handy. Absolute's going to maintain the angle of the object much better than offset would do. Now, in terms of width, if you're working in, say, architecture, and you know that, like, that's where width, depth, and percent, if you know, like, you have a blueprint of your architectural, thing you're supposed to be creating, and you know that, okay, I know that every bevel width should be 3 inches, then hey, that's what you just input that. You go to width and you put in the 3 inches or the however much that would be in meters. And it's the same with depth. I know that every bevel should be this big. I know that every bevel should be this much depth in it. So therefore you do that. Percentage, I know that I want all of my bevels to be this percent, right? I want a 3% bevel on every, edge, right? Then you choose that one. And so that's kind of the difference between the various width types. The last thing I wanted to show you is, what's the difference between doing the edge versus the vertex. We already know that the visual difference that you can see, which we kind of demonstrated here. Let's see, let me get rid of this one here. We already demonstrated some of the visual differences. So as you can see here, beveling along the edge is going to bevel the edge, beveling along the vertex is going to bevel the vertex. Now, how does this add up right here? So essentially, we know that when we were doing the offset and we did the edges for the offset, we know that, and bear with me just a moment here, we know that, and we're looking at it like this. Let me hide these. And we're looking at it from the orthographic view. And this is a 6-inch measuring stick. We know that it's from this edge to this edge, which is where we're going to get that. Well, what about if we were using vertices? Well, we said it was the same, right? Well, let's keep going. Does it work the same with all of these, right? So does it always measure in that same way? So we said that width along the edges was the width of the bevel, right? But if we were to select vertices instead of edge, watch what happens. We can see that it's still the 6-inch amount, but it's this width right here is, and if we can especially tell if you look at it from the orthographic view and you turn on X-ray, you can see that this is, if I were to do one corner to one corner, this is a much bigger bevel than what we're getting with that same amount. And I don't really know why that happens, right? I don't know. I don't have like a measuring to understand that. If you do, please let me know in the comments. I'm very interested in that. If we were to go up and do the depth situation here, we know that it's measuring from the original corner into the depth of this thing, which would be 6 inches, right? But what about if we were to switch this to vertices? Well, this one actually doesn't make sense either, because we have the same measuring stick, which is at 6 inches, but it actually goes deeper. So I'm not exactly sure what's going on with the vertices and how to measure that, other than just visually, but it doesn't seem to operate by the same principles as you see using the edges. And the same can be said of the percent, though, does work, which makes sense because it's kind of like it's, you know, it's a pretty standard situation here. So if we were to do 7.66, it's going to measure it perpendicularly here, as you can see, and it's just going to do that just like we would expect, right? And then absolute, with the absolute situation here, if we were to measure this along vertices, does it also add up here? No, it doesn't. It doesn't add up to what we would expect it to if we were, you know, so the way that the vertices and the edges are calculating how much bevel comes off makes sense with the edges. With the vertices, I'm a little confused. And like I said, if you have any thoughts on this, please let me know down in the comments. I'd be very interested in hearing your thoughts on that. And at the end of the day, you just have to, you know, it does come back to maybe just doing a little experimenting to figure out what's going to work best for your situation. You know, if you're kind of messing with it and you're going like, oh man, that doesn't really look right. I think this could look better. Let me try a different one. That's honestly, you know, the best thing you can do. But in reality, unless you know the specific, you know, amount that you want to do, whether it's the percent, the depth, or the width, you're probably going to choose absolute or offset. And generally speaking, if you're trying to maintain that angle, you're going to go with absolute there. But at the end of the day, just judge by visual and what looks best. But I did want to give you an overview of what these width type means, as well as showing why not applying your scale can cause bevel issues. I hope that was helpful. Thanks so much for watching this tutorial. I hope you enjoyed it and gained value from it. And until next time, always remember the 3 P's: patience, perseverance, and passion. I'll see you in the next one.